All right, so we're going to talk about something today called completing the square. We're going to talk about something today called completing the square. Let me just make sure I got the right examples here. All right. So, what do I mean by this and what's going on? So, this is still looking at quadratics. So, if you remember, if I have x squared plus, let's say 3x plus 2, right? Since a is equal to 1, then I can say two things that multiply to give me 2, but those same two things add to give me 3. And that's 1 times 2, 1 plus 2. So you have x plus 1 times the quantity x plus 2. So the quantity x plus 1 times the quantity x plus 2. I multiply that out, and it gives me x squared plus 3x plus 2. Okay, so we understand that. What we want to do here in completing the square is look at situations in which this trinomial, this quadratic right here, can be a perfect square. Now, what do I mean by that? Well, if I look here, x plus 1 times x plus 2, these two are not the exact same thing. But there are quadratics that when you factor them, they are the same thing. I'll give you an example of one. X squared plus 6x plus 9. The two things, remember, a is equal to 1. So in that case, I want two things that add to give me 6, but multiply to give me 9. Well, the two things that multiply to give me 9 are 3, and those are the same two things that add to give me 6. So notice it's the same number, right? So we would have x plus 3, the quantity x plus 3 times the quantity x plus 3. That's the same thing as the quantity x plus 3 squared. This squared means we're going to multiply this quantity twice, just like we did here. So this would be a perfect square. Okay, so in the case right here, we can, this is a perfect square. So when we talk about completing the square, what we mean is we have x squared, let's say plus 10x, and then we're going to look at plus c. Okay, so this is the c. Obviously, your a is 1, your b is 10, and then your c doesn't have anything. It's just c. Okay, we're trying to figure out what c is. Basically, we're going to put the number in for c that makes this a perfect square, that makes this something plus something squared. That's what we're going to do. And so when I look at this expression, x squared plus 10x plus c, what number can I put in for c to where I have a perfect square? So how do I figure that out? Well, if we look back at this problem here that we worked on, Notice that my 9, let's say I didn't know what 9 was. I know that I needed two numbers that add to give me the central number. And those same two numbers have to multiply to give me this number. So if I know my middle number, and I know that it has to be the same number to add to each other, I can divide that middle number by 2. And that gives me the number that I add to itself to give me 6. So then here, this number is going to be that number times itself. So let's look at that here. For 10, if I take 10 and I divide it by 2, I get 5. So the two numbers that add together to give me 10, those same two numbers have to multiply together to give me my C, which is 25. 5 times 5 is 25. So that's how I know it's x plus 5 squared. And this number C here, that would be 25. So what we do is we take the B, we divide it by 2, then we square it. That gives me my C. Okay. All right. So let's review that. When we complete the square, we're going to take our quadratic, take our middle term B, divide it by 2, and then we're going to square it, and that gives us the C. If I do that, then I'll have a perfect square. So if I have x squared, and as long as a, I should have mentioned that, as long as a is equal to 1. Okay, so if I have x squared plus, let's say 13x plus c, what does c need to be in order to have a perfect square? Well, this isn't a good one because 13 isn't going to divide evenly by 2. So let's say 14. Okay, so I take my 14, I divide it by 2, and I square it. So 14 divided by 2 is 7. And I'm going to square it. 7 squared is 49. So my C then becomes 49. And you can see it because the two numbers that multiply to give me 49, that add to give me 14 are 7. 7 plus 7 is 14. 7 times 7 is 49. So the two numbers that I add together to give me 14, they multiply together to give me 49. We found that to be 7. So I took my 14, I divided by 2, that's where the 7 comes from. And the 7 square, I square that, that's where this comes from. That equals 49, that's my C right there. Okay. All right, let's do another example. Let's do one with a minus sign. Let's do minus 14x plus C. Okay. What's going to change here? So here, if I take my middle term, right, my A is equal to 1. My B is equal to negative 14. And then I'm trying to find my C. So my middle term here, the coefficient there is negative 14. And I'm going to divide that by 2 and square it. And that'll give me my C. So negative 14 divided by 2 is negative 7. We're going to square that. Negative 7 squared is positive 49. So my C is 49. Okay, so I now have x squared minus 14x plus 49. Well, let's check that. What two things add together to give me negative 14? Those same two things must multiply together to give me positive 49. And we already found it. It's here. It's half of the 14. So negative 7 plus negative 7 equals negative 14. And negative 7 times negative 7 gives me positive 49. So for C, I put in 49, and that is completing the square. And we say the square because when this is then factored, it's x minus 7 quantity squared. X minus 7 times x minus 7, or x minus 7 quantity squared. All right. Now we're going to look at solving equations using completing the square. So we have x squared minus 4x minus 38 is equal to negative 6. All right. And the directions on your homework will say solve by completing the square. All right, so what do we do? What do you mean complete the square? Because up until this point, we've only seen things look like this. X squared minus 4x plus c. We could do that and find out what c needs to be for this to be a perfect square. Well, that's actually exactly what we're going to do. So in order to do that, I'm going to move this negative 38 to that side of the equation. Okay, so I'm going to add 38 to both sides of my equation. So negative 6 plus 38, that's going to equal 32. Okay. All right. And obviously negative 38 plus 38 is 0. So this is just x squared minus 4x. All right. Now we can come up with this third term right here, plus whatever this is going to be, in order to complete the square. Okay. So what does that need to be? Now, if I add something here, I have to add the same thing on the right side of the equation. I can't just add something here and not do anything to this side, right? If I add something here, I need to add it here. Now, I don't know what I'm adding yet because we haven't done the work to complete the square. But once we do, whatever number I put here, I will also put here. All right. So in order to complete the square, I'm going to take my middle term, the coefficient, and divide it by 2. And that'll be my third term. And whatever my third term is, I'm going to add that to both sides of my equation here. All right. So negative 4 divided by 2 is negative 2. And negative 2 squared, positive 4. So I'm going to add 4 to there and there. So now, here on the right, I have 32 plus 4. So that gives me 36. And then here I have x squared minus 4x plus 4. That's now a perfect square, right? And it's going to be this middle number of -2. Because -2 times -2 gives me +4, and -2 plus -2 gives me -4. So I have x minus 2 squared, and that's equal to 36. All right. So now that I have this, I've completed the square. X minus 2 squared equal to 36. This right here is the completed square, and I have that equal to 36. Well, now I can solve for x. I can solve for x by taking the square root of both sides. So the square root of x minus 2 quantity squared is just x minus 2. And then 36, the square root of 36 is plus or minus 6. And where am I getting that? Because either 6 times 6 is 36, or -6 times -6 is 36. Now we could technically put a plus or minus here, but again, that's actually going to wash out with this plus or minus, so we only put it on one side. Okay, because if both sides are plus, then that's the same thing as having just a +6 there. If both sides are negative, it's plus again. If you have positive, negative, or negative, positive, that's the same thing. Okay, so then what we're left with is x minus 2 is equal to plus or minus 6. So we have two things this could end up being. X minus 2 could be 6, or x minus 2 could be -6. In this case, I'm going to add 2 to both sides. X is equal to 8. And on this one, I'm going to add 2 to both sides. X is equal to -4. So x can be either -4 or 8. A little bit more height there so we can center that. Okay. Let's do another example there of completing the square as we are solving, using this to solve equations. All right. I'm going to do x squared plus 4x minus 35 is equal to -3. Okay. In order to get this into a form where I can complete the square, I want to get rid of my c. I'm going to move that to over here. So I'm going to add 35 to both sides. So I have x squared plus 4x is equal to 32. Okay. Now, I'm going to do the same thing. My middle term, or I'm going to have, in order to complete the square, I'm going to add something here, and then this will be a perfect square. but I can't just add something here on the left. I need to also add it on the right. So I'm going to take that middle term. Remember, I need two things that add to give me 4, and those same two things are going to multiply to give me this number that's going to go here. Because I add it to this side, I'm also going to add it over here. So two things. It's always good to remember why we're doing what we're doing. So these two things add together to give me 4, and those have to be the same two things that multiply to give me this number. Now, in order for it to be a perfect square, they have to be the same number here and here. That's why we do 4 divided by 2. Okay, that gives me 2. So 2 plus 2 is 4. And then that's where the squared comes from, is here for my C, you have 2 times 2. And in this case, that also equals 4. So then I have plus 4 plus 4. Okay. So now I have x squared plus 4x plus 4 is equal to 36. X squared plus 4x plus 4, that's going to be x plus 2 times x plus 2. Two things that multiply to give me 4, that add to give me 4, that's 2 and 2. Notice these two are exactly the same. That's why we can write it as x plus 2 quantity squared is equal to 36. Now, we can take the square root of both sides to get rid of that square, and x plus 2 quantity squared square rooted is just x plus 2. The quantity 36 square root is plus or minus 6. Because again, 6 times 6 is 36. And negative 6 times negative 6 is 36. All right, so this could be two answers. X plus 2 is equal to positive 6. And x plus 2 is equal to negative 6. So if we do the first one and we subtract 2 from both sides, then minus 2 gets rid of that. And then 6 minus 2, that's going to be a positive 4. And then here, if I subtract 2 from both sides, get rid of that, x is equal to minus 6 minus 2, that's a negative 8. So it's the exact opposite of what we got before on our last one. Probably notice a lot of the numbers were the same as we were working that out. But this one, x is then 4 or negative 8. Right. Let's do another one. Okay, let's do x squared plus 16x minus 50 is equal to 7. Okay. X squared plus 16x minus 50 is equal to 7. So the first thing we want to do, we're going to solve this by completing the square. Okay. So by quick review, if we just focused on completing the square, or we just focused on x squared plus, let's say 3x plus 2 is equal to 0. You know two things that multiply to give me 2, but they add to give me 3, right? Well, that's going to be 1 and 2. So you have x plus 1 times x plus 2 is equal to 0. So here, notice that we didn't have to complete the square, okay? And then we got this, x plus 1, x plus 2. So x, as far as what the answer is, can either be -1 or -2. Now, here, in order to complete the square, and this is just to kind of remind us what we're doing in terms of factoring. The first thing I want to do is add 50 to both sides of this equation. And I'm doing that for a specific reason. That is to get the x squared plus 16x by itself, because I can do a complete the square on that. 50 plus 7 is 57. And these two obviously cancel. All right, now I want to complete the square, which means x squared plus 16x plus something is going to give me a perfect square. And I need to add that plus something over here too. So what is that perfect square? Well, that perfect square, just like over here, two things that add to give me 16, but they multiply to give me this right here. We don't know what this is. We'll just call that C. All right. But they have to be the same number. Look here how these are not the same number. Therefore, it's not a perfect square. X plus 1 is not the same thing as x plus 2. Okay. For them to be a perfect square, they would have to be the same. So that's why we take this 16 and we divide it by 2. Because that gives us two numbers identical to each other that add together to give me that 16. And if I'm adding the 8 and 8 to get 16, then I have to multiply the 8 and 8 to get this number. If I multiply 8 times 8, I get 64. All right, so now I have x squared plus 16x plus 64, there's my perfect square, is equal to, and then let's just work out 57 plus 64 over here. $121. Yep. 121. All right. Now, this is a perfect square. The two things that add to give me 16, that multiply to give me 64, that's x plus 8 and x plus 8 again. So because these are the same, I can write this as x plus 8 quantity squared. Now, I can take the square root of both sides. Right. This is going to be x plus 8 is equal to the square root of 121. I think that's 11. Is that right? Let me see. Let me just multiply 11 here. Yeah, that is 11. So plus or minus 11. Okay. So now we're going to have two answers. X plus 8 is equal to positive 11. And x plus 8 is equal to negative 11. So in both cases, I'm going to subtract both sides by 8 minus 8 minus 8 minus 8 minus 8. All right. So here x is positive 3. And here x is equal to negative 19. So x is equal to negative 19 and positive 3. A lot going on with completing the square, but it comes in very handy. Factoring is a huge part of what we do in Algebra 1. Factoring and graphing, those are the two main skills. All right. Let me look at give me just a second here. What time is it? Yeah, we got time for that. Let me see. Okay. So let's do one now where a is not equal to 1. So let's look at 7x squared plus 14x minus 59 is equal to negative 3. All right, what do we do here? All right, so we're going to start this off the same exact way. I'm going to add my 59 to both sides to get rid of this C term here. Okay. So this leaves me with 7x squared plus 14x, and that's equal to 56. All right, and same thing. I'm going to add something here that's going to make this whole thing a perfect square, and I need to add the same thing there. Now, here's what's different. I can't just take the 14 and divide it by 2, because what happens is it's not going to be x plus something or x minus something squared, because I have this 7 right there. So the first thing that we do is we factor out the leading coefficient, okay? So let me write it without these placeholders here, so it makes a little bit more sense. Okay, here you can see clearly I can factor out the 7, and I'm left with x squared plus 2x is equal to 56. Now, I haven't added, multiplied it, or divided anything. I've simply just factored out of this side 7. Okay. Now, here, what we notice is we can actually divide both sides by 7. Because this 56 divided by 7 gives me 8. So now I have x squared plus 2x is equal to 8. So that's a little bit easier to work with. Okay. So now I'll look at adding two things to both sides. Two things that multiply to give me this number c, but they will add together to give me that number there, which is 2. And I can do that because now my leading coefficient here is 1. Okay. So what is that? Well, that's this number here divided by 2. So 2 divided by 2 is 1. 1 plus 1 is 2. 1 times 1 is 1. So 8 plus 1. All right, so that gives me, I'll go ahead and move this up. You guys have a little bit clearer thing to look at. So the last line on here was x squared plus 2x plus 1 is equal to 8 plus 1. Okay, so again, that's x squared plus 2x plus 1 equal to 9. Two things that multiply to give me 1, add to give me 2 is 1. X plus 1 times x plus 1. X plus 1 times x plus 1 is x plus 1 quantity squared equal to 9. Take the square root of both sides. X plus 1 squared, square rooted, is x plus 1. Square root of 9 is plus or minus 3. So two answers. You can have x plus 1 equal to positive 3. The other thing that I can have is x plus 1 is equal to negative 3. X is equal to 2. X is equal to negative 4. All right. Moved a little quickly through that one. Give you a chance to write that down because I want to move on to one more concept when a is not equal to 1. But as a quick review of what we just did, remember here, after adding the 59 to both sides, we got 7x squared plus 14x. So when I don't have a 1 here, what we'll need to do is always factor out that leading coefficient. And in this case, we could easily factor out the 7 out of 14. But what do we do when that's not as convenient? So let me show you kind of a situation like that. So okay, let's look at 8x squared plus 16x plus 6 is equal to 0. Okay, so the first thing we'll do is move that 6 to the other side, so I can complete the square. All right, then I'm going to factor out the leading coefficient there, which is 8. And in this case, it kind of works out as well, because if I factor an 8 out of there, that's a 2. But what doesn't happen is I can't divide both sides by 8, okay? And so, but in order to complete the square, I need to be able to have these terms and complete the square in here. So what I'm going to do is I'm actually still going to divide by 8 on both sides. And then over here, negative 6 over 8 can simplify to negative 3 over 4. If I divide the top and bottom by 2, I get negative 3 over positive 4. So I still get rid of my 8 on the left side, and I have my x squared plus 2x. So I do the same thing here. Two numbers that multiply together to give me my number here. And those same two numbers here add together to give me my middle term of 2. When I take the 2, I divide it by 2. That gives me 1. 1 plus 1 is 2. 1 times 1 is 1. So that's what I'm adding to both sides. So on the left, I have x squared plus 2x plus 1. And that's equal to negative 3/4 plus 1. So what is that? Negative 3/4 plus 1 is going to be, I can change that to 4 over 4. That gives me a positive 1/4. Okay. So now I'm going to rewrite what I have there at the bottom, at the top of this. X squared plus 2x plus 1 is equal to 1 over 4. All right, so here, this is a perfect square. So if I look at two things that multiply to give me 1, that add to give me 2, that's x plus 1 and x plus 1. And that's equal to 1/4. X plus 1 times x plus 1. That's x plus 1 squared. Now I'm going to take the square root of both sides. The square root of x plus 1 squared is x plus 1. And remember, if I have the square root of a fraction, a over b, that's the same thing as the square root of a over the square root of b. So here, that's going to be the square root of 1 over the square root of 4. So x plus 1 is equal to, the square root of 1 is 1, and the square root of 4 is 2. So x plus 1 is equal to 1/2. I'm sorry, that's going to be plus or minus, because the square root of 1 is plus or minus 1, square root of 4 is plus or minus 2, so this is going to be a plus or minus 1/2. So then I will have two answers. X plus 1 is equal to positive 1/2, and x plus 1 is equal to negative 1/2. Subtract 1 from both sides here, we have negative 1/2. And if I subtract 1 from here, I have negative 3/2 or negative 1/2. So x is equal to negative 1/2 and negative 1/2. Okay. We've got time for one more. Let me do one that's a little bit more difficult. All right, here we go. This will be a fun one. So if we have 8x squared plus 7x minus 5 is equal to negative 9 plus 6x squared minus 12x. We're going to solve this by completing the square. All right, so what we can see is we've got like terms on both sides. So let's get some of those like terms together. I'm going to subtract 6x from both sides, or 6x squared, I should say. And that's going to leave me here with 2x squared plus 7x minus 5 equal to negative 9 minus 12x. So now I'm going to add 12x to both sides. Okay, so this leaves me with 2x squared plus 19x minus 5 is equal to negative 9. All right, so now I've got it into a form that we've kind of been normally looking at it. And I'm going to add the 5 to the other side so that I can complete the square on this side. So that leaves me with 2x squared plus 19x is equal to negative 4. All right. So now I'm going to factor out the 2. And this is a good example of what I was trying to show you earlier, because you can't take 2 out of the 19. So what do I do here? So I'm going to actually still factor out the 2. And this is going to give me x squared plus, now watch this. This is going to be 19 divided by 2x. Okay. Now, where am I getting that? Notice that when we factor this 2 back in, it has to give us this right here, 2x squared plus 19x. Well, how do I get that multiplying a 2 in? Well, this first term here is easy. You've seen it before. 2 times x squared is 2x squared. But this middle term now, 2 times 19 over 2 times x, the 2's will cancel, and I'll be left back with my 19. So when we pull a 2 out, I can show that as divided by 2. So when I multiply it by 2, those inverting functions result in just giving me back the same number. So now I'm going to divide both sides by positive 2. So it gets rid of it on the left. And on the right, negative 4 divided by 2 is a negative 2. Let's go on to another sheet here. I'm going to rewrite what we just had, x squared plus 19 over 2x quantity. We had a 2, we divided it by a 2. We had a negative 4 over 2. Okay. So obviously it's divided out, so we're left with x squared plus 19 over 2x is equal to a negative 2. All right, so now I can perform the square. So I can add it to here, add it to here, in order for it to be a perfect square. Now I want 2 things that I add together to give me my middle term of 19 over 2. And then what do those 2 things multiply together to give me? Now, this can be a little complicated. How on earth do I find, well, half of 19 is 9.5. And then I want half of that, half of 9.5 here and here. So that can get a little confusing. So that's why we take half of 19 and we split that in half. And then we square it. So 19.5 divided by 2, okay? So 19.5 divided by 2 okay, that's the same thing as the numerator multiply by the inverse of the denominator. If the denominator is 2, the inverse is 1/2. And when I multiply that, 19 times 1 is 19. 2 times 2 is 4. So that is half of 19 over 2. So those are the two things that I can add together that will give me 19 over 2. Well, how does it give you 19 over 2? Well, 19 plus 19 over 4 common denominator, which means the end result will have a common denominator, 4. 19 plus 19 is 38, right? 9 plus 9 is 18. 8, 1, 2, 3. Yeah, 38. Now, if I divide the top and the bottom by 2, then I get 19 over 2, which is my number right there. So I want to do 19 over 4 times 19 over 4 in order to give me the number that's going to go right here and here. All right. So for that, I need to multiply across the top. 19 times 19 divided by multiply across the bottom. 4 times 4 is 16. So now I just need to find out what 19 times 19 is. I'm going to do that off to the side here. 9 times 9 is 81. 9 plus 8 is 17. 1 times 9 is 9. 1 times 1 is 1. Add those together. 361 over 16. 361 over 16. That's going to be my number here. 361 over 16 and 361 over 16. All right. Now over here, I'm going to subtract 2 from it. So we just rewrite that. We have x squared plus 19 over 2x plus 361 over 16 is equal to -2 plus 361 over 16. All right, so that -2 I need to change into a fraction with positive 16 in the denominator, which means I'm going to, this is -2 over 1, which means I multiply top and bottom by 16, and that's going to give me -32 over 16 plus 361 over 16. And then the left side here remains the same, x squared plus 19 over 2x plus 361 over 16. All right, so now I want to subtract 32 from 361. Let me do that off to the side here. 361 and subtract 32. 9, 2, and 3. So 329. So positive 329 over 16. And this, of course, is x squared plus 19 over 2x plus 361 over 16. All right. So now my perfect square here, the two things that add to give me 19 over 2 that multiply to give me 361 over 16 are x plus 19 over 4 times x plus 19 over 4, 329 over 16. This x plus 19 over 4, since I'm multiplying the same thing twice, I can square that. X plus 19 over 4. And then that's quantity squared. Whoops, equal to 329 over 16. I realize I'm like 6 minutes over, so let me hurry up and finish this. So square root of both sides. That's going to give me x plus 19 over 4 is equal to, and again, I'm going to do the square root of 329 over the square root of 16. Square root of 16 is 4. Let me see if 329 has a clean square root. It does not. So we can leave that as 329. And then to solve for x, and this would be plus or minus, and I won't finish solving this because, whoops, we are way over time. But x would equal to plus or minus square root of 329 over 4 minus 19 over 4, which would be the square root of 329 minus 19 all over 4. All right. That was real quick there to get to the end. But let me see. Let me double check that with. Yeah, they've got it in decimal, and I don't have my calculator, so I'll just double to make sure it's okay and issue a correction if I need to on the video. All right, you guys have a good night.